Hi guys, welcome back to the channel. Jag here. Today we're actually going to cover Chemistry 11 and we're going to move on with writing skeleton equations. So one more time, this might be like a review from grade 10 science, and we're just going to go through as a refresher. We're going to refresh our memories on how to write these skeleton equations. Alright, so let's try an example from the textbook here. Okay, I'm going to write down kind of like a word equation here. Okay, we're going to try calcium plus fluorine. Okay, and I'm going to put the arrow, again the arrow means yields or it produces calcium fluoride. Okay, so I'm just going to write it here, calcium fluoride. And one more time, just watch the actual spelling, okay, for fluorine. Make sure you're putting the U before the O. Okay, so some teachers again might take off marks for spelling. Okay, so you don't want that. Alright, so here, this is the actual word equation, okay, for this chemical reaction. What we're focusing on today is how to write the skeleton equation. Okay, so with that, we're going to start here. So it's calcium. So again, you could just look in the periodic table. Calcium is Ca, so I'm just going to put Ca by itself plus the fluorine, okay. Fluorine is also a diatomic molecule. So again, I'm not going to just write F by itself. Diatomic means there are two atoms of fluorine that are attached together to make sure that fluorine is stable in the environment. So I'm going to write F2. I'm going to draw an arrow here. It's going to form calcium fluoride, okay? So one more time, in the last video we did go through how to name the compounds and write the formulas. So I'm going to write calcium. You can check in the periodic table. Okay, the charge for calcium is 2 plus. I'm going to write it at the top here, okay, so everyone can see it. And then we're going to write fluorine, which is F. If I check in the periodic table, fluorine has a charge of 1 minus. I'm going to put 1 minus there, just like that, okay? And again, using the crossover method, we want to make sure we're crossing these charges to the opposite side, okay? I'm going to draw arrows here. So it becomes basically Ca1. Okay, and the numbers have to be on the bottom as subscripts. Okay, and then F, which is going to be 2. I don't have to write the 1 here. Okay, all the numbers greater than 1 is what I'm indicating for the subscripts. So it's going to be CaF2, like that. And so I'm just going to rewrite the calcium plus the fluorine. It's going to form calcium fluoride. Alright, so this is actually the skeleton equation. As soon as I write the skeleton equation, I have to make sure it's balanced. Now, I don't need to. What we need to get used to is just writing the numbers in front, and I should be able to see and make sure it's balanced without drawing out the table. Okay, the table is only if you're having a lot of difficulty with balancing the equations. That's when I would draw out the table. So if I look at this equation is pretty simple here, okay? I can see that there is one calcium atom on the reactant side, one calcium atom is on the product side. For fluorine, there are 2 atoms of fluorine on the reactant side, okay? On the product side, I also have 2 fluorines. So this is actually the balanced equation. I don't need to actually add any numbers in front of the elements or the compounds. And that's going to be my final answer. Alright, so we're going to try actually just one more example on the board. So I am going to erase this. Okay, but make sure you are always checking, okay? As soon as you write the skeleton equation, I have to make sure it is balanced. Alright, if it's not balanced, the teacher is going to take some marks off again, and we just don't want that, okay? That's something we're trying to avoid all the time. So let's try this one. So we're going to do zinc reacts with chlorine, okay? And it is forming zinc chloride. So I'm going to put that down here. Zinc chloride. All right. It might say chlorine or chlorine gas. It doesn't really matter, okay? These are all the halogens, and they are gases usually at room temperature. Except for bromine, okay? Bromine is a liquid at room temperature. So that's something good to remember. So let's try writing the skeleton equation for this reaction here. So zinc is Zn. All right. Again, chlorine is diatomic, so I'm going to put Cl2. And if you're not sure about the elements that are diatomic, if you look in the periodic table, it's actually like an upside down L, okay? So let's write it down here so we can see. So diatomic. The diatomic molecules here start off with hydrogen. Although you see hydrogen is actually found in group 1, okay, in the periodic table for simplicity. I have fluorine, okay, chlorine, bromine, and basically just follow that upside down L in the periodic table here. Okay, I have iodine as well, okay, and all of them are diatomic, okay, as well as nitrogen and oxygen, and they all basically exist as in the environment as two atoms of this element, and they're combined together chemically. All right, and that's the most stable form of these atoms and elements here. So let's go back to the example that was just like a side. I'm forming zinc chloride. Again, I'm just going to write it here, zinc and chlorine. Okay, check the periodic table. Okay, zinc also has a charge here of 2+. Okay, chlorine has a charge of 1-. And when I cross it over to the opposite side, the 1 is going to come in between the zinc and chlorine, and the 2 is going to go to the opposite side, okay, where you have the chlorine. So you're going to take the charges off. Okay, and this is basically the compound that is forming for zinc chloride. Again, I wrote down the skeleton equation. I'm going to just make sure that it is balanced. On the left side, I have 1 atom of zinc. On the right side, there's also 1 atom of zinc. And then take a look at the chlorine. There are here 2 atoms of chlorine on the left side. There are 2 atoms of chlorine on the right side. So this is the balanced equation. But again, remember, all the equations are not going to be just balanced like this. They're very complex types of equations where I have to make sure I am balancing all of them at the end, okay? Again, if you think you have some trouble with balancing the equations, I would make sure I'm drawing out the table. Okay, put all the polyatomic ions together. I don't need to separate them. And then you can put the other elements separately. Okay, just make sure it lines up and you're counting the number of atoms. Alright, so this video basically covered skeleton equations and how to write them. This should have been like a review from grade 10 science, the chemistry section. And I hope that was a good refresher for everyone before we move on to the next content in Chemistry 11. So thank you for watching. Make sure you're hitting on the subscribe button and also press on the like button below. And I can bring out more content for Chemistry 11 to help everyone out. And thank you for watching one more time, and I will see everyone in the next video. Bye!